Hi guys, it's Simon C. Welcome to this new AI radar. Today I have 3 news about adversarial examples for you. Kim Zetter for Vice reports that Australian researchers, in order to trick Cylance product AI-based antivirus engine into classifying programs like WannaCry and other malware as benign, they took strings from an online gaming program and appended them to malicious files. The method doesn't involve altering the malicious code, as hackers generally do to evade detection, points out Zetter. Instead, the researchers developed a global bypass method that works with almost any malware to fool the Cylance engine. The researchers successfully tested their attack against the WannaCry ransomware, the one that crippled hospitals and businesses around the world in 2017, the more recent Samsung ransomware, and the popular Mimikatz hacking tool, and hundreds of other unknown malicious files. A motherboard expert said that the method usually works pretty well, until you have some corner cases where you can't just make the model work. Ryan Permech, founder and chief scientist of Cylance, also the architect of Cylance machine learning engine, said they do use signatures and hard-coded heuristics in the product as well, and don't entirely rely on the machine learning, but the AI does take precedence in detection. He acknowledged to motherboard the potential for the kind of bypass the researchers found, however. In all of these AI scenarios, models are probabilistic. By training for what is a good file, we learned attributes of that, and it's entirely possible that we overestimated the goodness of that. One of the interesting parts of being basically the first to take an AI-first approach is that we're still learning. We invest a lot in adverse research, but this is still an evolution. Artificial intelligence is great at identifying objects in images, but it's still pretty easy to mess it up by means of adversarial examples, which features small perturbations that cause an AI system to misclassify inputs like images and even audios. You can use that to create more robust systems though. Indeed, Ivan Ackerman for Spectrum reports that to make robot grasping more robust, researchers at UC Berkeley's Laboratory for Automation Science and Engineering, directed by Professor Ken Goldberg, are designing objects that are as difficult as possible for robots to manipulate. Robots have a hard time grasping these so-called adversarial objects. Adversarial objects are an extension to the concept of adversarial examples and adversarial images to robot grasping, with physical adversarial objects carefully designed to be tricky for conventional robot grippers to pick up. All it takes is a slight tweak to straightforward 3-dimensional shapes, and the standard 2 fingers will have all kinds of trouble finding a solid grasp. Starting from a cube, the adversarial object evolves to become increasingly more difficult for a 2-finger gripper to pick up. When it tries to pinch against an angled surfaces, the object twists and slips off. The key to these adversarial objects is that they look easy to grasp, but at least for a 2-finger gripper they are not. The point of all of this is to develop tools that will help make robot grasping robust enough to reliably work in the real world. In some preliminary real-world testing, a parallel jaw gripper with point contact fingers tried to pick up some of these adversarial objects. In each case, the computed grasp was predicted to succeed 100% of the time, but the actual success rates on the adversarial cubes and more complicated polygons was just 13%. The researchers say that they plan to test these objects with different gripper types as well as suction grasp to see if they can come up with the most adversarial objects. James Vincent for The Verge reports that a group of researchers from USA, Berkeley, the University of Washington, the University of Chicago created a dataset of some 7,500 natural adversarial examples. They tested a number of machine vision systems on this data and found that their accuracy dropped by as much as 90%, with the software only able to identify just 2 or 3% of images in some cases. The so-called natural adversarial examples are images which represent common objects, but that are able to fool an AI system though. For example, a candle is mistaken for a nail and a snail for a hummingbird. The data will hopefully help train more robust vision systems. The researchers explained that the images exploit deep flaws that stem from the software's over-reliance on color, texture, and background cues to identify what it sees. OpenAI research suggested recently that rather than looking at images holistically, considering the overall shape and content, algorithms should focus in on specific textures and details. Okay guys, it's all for today. See you next time with AI Radar. Bye.